All right, class, welcome back to Algebra 3 / Trig. Today is Monday, April the 13th. Our proverb for the day is found in the 8th chapter, 31st verse. Rejoicing in his inhabited world, and wisdom's delight was the sons of men. Was with them. And so I'm just thankful that wisdom was available and still is. Today we're studying section 2.1. Linear equations in two variables. So the difference between chapter 1 and chapter 2 is chapter 1 was one variable, so we graphed everything on a number line. In two variables, everything is going to be graphed on the coordinate or the Cartesian plane. So I have here for you four basic coordinate planes, and we're going to put the choices here for you for what type of slopes may be possible. So we have a slope of a line slanted this way, slope of a line slanted this way, slope of a line straight across, and slope of a line straight down. And so we need to decide which is which. If it is rising from left to right, this is said to be a positive slope. If from left to right, it's the next one going across the top, from left to right falls, is a falling slope or negative slope. Okay, you've seen all these in Algebra 1 and in geometry class, a little bit in Algebra 2. This slope, if it is straight across, is not changing from the left to the right. This is said to have a slope of 0. Sometimes you will see the word spelled out. Okay? It is not changing from left to right. This particular graph is not a function, okay? It does not pass the line test, the vertical line test. It has no slope. And so I typically will use the word no slope. Much different than a 0 slope. 0 straight across, no is up and down. Your author lots of times will use the word or term undefined or undefinable. Okay? Sometimes you may even see or hear me say the term error. Okay? You cannot divide by 0 is why this is going to happen. Okay, so I've chosen some even exercises out of this section 2.1. I'm going to move our camera over just a little bit so we can do all of these at once. I chose even exercises, so number 16, number 20, and number 22, you're asked to identify the slope and the y-intercept. So I would put it in slope-intercept format, which is y equals mx plus b. B is the y-intercept. M is the slope. Okay? So the slope, for example, number 16 is what is in front of the x. Slope is a -1. The y-intercept, or b, is a -10. That's all you're asked to do. Identify the slope and the y-intercept. I do want you to write out the problems. All right. Number 20. I'm going to break the rules just a little bit. I'm going to leave the x on the left-hand side and say x equals a -5. Okay? This is a special type equation. And so if we were to sketch it, which you're not asked to do, but hopefully it'll help you. X at -5 looks like this. It is a vertical line. It has no slope. No slope, or a slope that is undefined. So an x equals is a special equation, has a special graph, and is a vertical graph. It does not matter what y value you pick, whether it's 1, x is -5. If you pick 6 for y, x is negative 5. If you pick negative 2 for y, x is negative 5. Whatever you pick for y, x is always negative 5. All right. Number 22, I do want it to be y equals, so I'm going to divide both sides by 3. And I get the equation y equals 5/3. It is also a special graph. Okay, special graph, y is 5/3, which is 1 2/3. So just a little bit below 2 has a special graph that is horizontal. It has a 0x. You do not have to write this down, but it is y equals 0x plus 5/3. Okay, horizontal line, 0 slope. It has a slope. The slope is 0. So you're asked, what is the slope? The slope is 0. The y-intercept is 5/3. Now back up to example number 20. What is the slope? The slope is undefined. If you're lazy, you might write no slope. What is the y-intercept? What is the y-intercept? Well, it doesn't cross the y-axis, so it does not have one. Okay? So these are the answers for number 20, the answers for 22, and the answers for 16. All right, number 26, you could work it two ways. You could sketch it, but I think first off, I'm just going to throw out the slope formula. So you'll see it on ACT, which is slope is the change in y, or delta y, over the change in x, or delta x. There are 4 values here, and there are 4 up here. You determine which one you want to be 0.1 and 0.2, which is what I'm going to do. That means you need an x and a y for 0.1. These are sub 1s. And an x and y for 0.2, and these are sub 2s. Plug them into the formula. Make sure you're subtracting each time. You get a negative 8 minus 0 over 0 minus 12. So I get a negative 8 over negative 12, or a positive, they both divide what? 4, 6, or a positive 2/3. Let's see if that actually looks right. Over 12 and up 0, and over 0 and down 8. I believe that could very easily have a slope of 2/3, or a change in y, which is 8, over a change in x, which is 12. Change in y over change in x, which is 2/3. So I believe we've done it right. All right, in example number 38, or exercise number 38, you're asked to come up with 3 more points that are going to fall on this line, and the point is over 1, up 1, 2, 3, 4, 5. Now, if the slope is undefined, I'll refer you back to those first 4 sketches. But it has to be a vertical line through the point 1, 5. Now you can do this by sketching. I think it's probably the easiest. What are 3 more points on this line? Well, how about over 1 up 0? How about over 1 up 1? How about over 1 up 2? The back of the book, or the answers, are going to say answers will vary. It's because there's an infinite number of points on this particular line. All right, hope that helps you out.